So we want to panel this six-sided shade sail using cross sections. You can see it's a wave shape. So the first thing we do is take a copy of the mesh and draw a line connecting the bottom left corner of the mesh to the top left corner, and then another line, again from the bottom to the top. Now the reason we're doing that is these lines will dictate the direction of the cross sections that will result from the cross section process, and the bottom will be at the bottom of the page, the top will be the top, which makes it very convenient when we come to compensation and paneling. Now we also need to make sure, as you can see here, we've scaled the line to make sure that it is longer than the total length of the mesh. So using the AutoCAD scale command, from the center we make it 3 times its original size. Now we're going to assume we want to split this into 8 fabric strips, therefore we need 9 cross sections, and we're going to ask for 7 extra cross sections. I've used 37 points because that is the density that this mesh has been built with, and we've also selected use simple mesh edges as cross sections. That will pick up the edge detail here. So we select, I'll make a copy of this, select the 2 cut lines and the mesh, and run the cross section tool. And what we can see is the 9 cross sections are represented by these cyan colored lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And in between we can see, let's get rid of the mesh, we can see the grey extra. Now the reason I selected 7 is that this will actually, with the 2 cyan lines on either side, will give us 9 cross sections, and as a result there are 8 spaces in between the cyan lines. This gives us better results when we're paneling these cross sections. So we can now delete the original cut lines, select everything, and then use the color marked polys, panel from color marked polys tool, and run the tool. And there are our 8 panels. And we can also see that the average width, after we did the cross sections in the first instance, we actually get a message from MPanel to tell us that the average spacing is 1659. If your fabric is narrower than this, then you would simply adjust the number of cross sections to suit your fabric width. Now another way to do cross sections is to use some of the functions inside the cross section toolkit to actually specify the fabric width. Now in order to do that, the first thing we need to do is we're going to make a single cross section through the center, and you can see that now gives us a new cut line. We can delete the old. Now we're going to specify cross sections from cut line and existing seam. So this is the existing seam, these are the cut lines. We use the same number of points of 37, and now we're going to specify the fabric width. Let's say 1700. Apply. Now first thing we do is select the seam, the mesh, and then the cut line, indicating the direction that we're going to create cross sections. Run the tool, and we can see a set of cross sections have been created, which when we make a panel from those, from a set of polylines, is 1702 millimeters wide, so close to the 1700 we specified. So using this procedure, we would continue, select the last of the cross sections that were created, again the mesh and the cut line, and run the tool again. There's the next batch. And then finally, this last panel, we don't specify the fabric width. We'll just leave this as unchecked. We have got the use single mesh edge as a cross section. That will create a series of curved cross sections. We'll fill in this final panel. And obviously repeat in the other direction. If we wanted to have a fabric width in the middle that was a full fabric width, then the first set of cross sections, instead of specifying 1700, we would specify half the fabric width this way and half the fabric width this direction to create a single panel in the middle that is the full 1700 fabric width.